Hello and welcome to lesson 1.6. So we've spent the last few lessons perfecting our factoring skills, and we're going to continue using factoring, but we're going to use it in a different way today. What we're wanting to do is actually use it to solve equations. Okay? Now, to use it to solve equations, we kind of need, or we do need, um, this zero factor property. It says this. So let's just say that I have two things being multiplied, like a times b, and I know that it's equal to 0. Well, then I know something from that, right? If I want to know what a or b is, then either a has to equal 0, or b has to equal 0, or both. A has to equal 0 and b has to equal 0. So when I have two things multiplied together set equal to 0, that means one of them or both of them have to be 0. So we can use this to try to solve some things. So let's pretend that I factored a polynomial and it was set equal to 0, but I just ignored the equal 0 part and I factored it. Well, whenever I factor something and it's set equal to 0, I have this same idea. I have two things multiplying to 0. I have this thing times this thing multiplying to 0. So what that means if I want to solve it is I should consider that x plus 2 could be 0 or x minus 6 might be 0. Either of these might be 0 or both of them might be 0. So they're both solutions that I want to consider. So I have two very easy equations now to solve. So for instance, this one I would subtract 2 from each side and x equals negative 2. Another possible solution is I need to get x by itself. I could add 6 to both sides and x could be equal to 6. So I can find solutions by just taking, as long as I have a polynomial equal to a 0, once I factor it, I take each factor and set them equal to 0 and solve. Now, as good practice, you should always check your work. I'm not going to bother checking this, but if I were to take negative 2 and plug it in, negative 2 plus positive 2 is 0. That makes it 0, and that does make this 0. If I put 6 and 6 minus 6 is 0, anything times 0 is 0. So those both work as solutions. So this kind of leads to pretty simple problems then. So if I were to just give you something like this, like, hey, solve this equation. Solve for x. And I tell you, like, x squared plus 2x minus, I'm trying to make up one on the spot. I have other examples, but I wanted a simpler example first. Let's see. Minus 15 equals 0. Solve for x. How would we do it? Well, first off, we notice that we're equal to 0. So let's see if we can factor this thing. And you should be getting more cozy with factoring. Let's see, it's a simple one with no coefficient out front. So let's just set x and x. Let's see, and what multiplies the negative 15 that adds to 2? That would be a positive 5 minus 3. Let's see, positive 5, negative 3 multiplies to negative 15. Positive 5 minus 3 adds to positive 2. Okay, great. And so if I want to continue solving this, all I need to do is take each factor, each binomial here, and set it equal to 0, because either this factor is equal to 0, or this one is, or both of them are, to make this equal 0. And so let's set the other one. X minus 3 is equal to 0. So we take each factor, set it equal to 0. Now I have easy equations to solve. I would need to subtract 5 from both sides. And so we found that x is negative 5. And here I would need to add 3 to both sides. And so we found that x is equal to 3. Great. So we found two solutions for x. I could plug both of these back in. Both of them would work. You could check them if you wanted to. Okay. Well, I could get even fancier with this. What if I were to do something like this? X squared minus 10x equals negative 24. And you're like, I don't know about this one. It's not equal to 0 and I don't even have a trinomial to factor. Well, we know enough algebra. I know that if I want it to be 0 on this side, I could add this 24 over to both sides. I could add it over so that I'll have nothing here. It'll be equal to 0. Now, 24 is not a like term because it doesn't have an x. It doesn't have an x squared, so that would just be tacked on to the end of this polynomial. So I'd have x squared plus minus 10x plus 24. Now this looks much more like something we can do like that problem. We should maybe try to factor it. Okay, let's see. Does this factor? That's a great question. Let's see. Are there any two numbers that multiply to positive 24 that add to negative 10? Let's see here. Well, I think I know of one. Negative 6 and negative 4. Check it with me. Let's see. Negative 6 times negative 4. Negative times a negative is a positive. 6 times 4 is 24. Negative 6 plus negative 4 is negative 10. Okay, so yeah, this is the these are the factors for this trinomial up here. And so that's awesome, great, perfect. Now I could just set each of them equal to 0. So x minus 6 equals 0, and x minus 4 equals 0. Oh, that's a sloppy 0. I'm sorry. Don't think it's a 6. And then I can solve this by adding 6 to both sides. And so I get one solution as x equals 6. And over here I have minus 4, so I can add 4 to both sides. And I will get x is equal to 4. So I get two solutions. Cool. Now I can go any level of difficulty on factoring. I can do one with a leading coefficient, like 2x squared plus 9x minus 5 equals 0. So we'll have to do a little bit of work. Let's see. Let's do the AC method. 2 times negative 5 is negative 10. So I need two things that multiply to negative 10 and add to, what's the middle term there? Add to 9. Add to positive 9. Let's see. What things multiply to 10? Add to positive 9. How about negative 1 and positive 10? Does that work? That is negative 10. That is positive 9. So we will split this 9x up into a minus 1x and a plus 10x. So 2x squared minus 1x plus 10x minus 5. Don't forget to bring down everything else equals 0. And so we'll now factor by grouping. Boom, boom. All right, I've grouped. What's in common here is they both have an x, so I can factor an x out. I'll be left with 2x minus 1. So I'm going kind of quick on the factoring stuff because we've spent a lot of time on it. Let's see, greatest common factor here would be a 5, so we're going to factor out a 5. If I factor a 5 out of 10x, that leaves me with 2x. If I take a 5 out of 5, there's nothing left, so I need something to hold that place, so a 1 equals 0. Yay, I'm very happy because notice that both terms have an identical part, a common factor. So I can factor out 2x minus 1 from both of them. If I take 2x minus 1 from this term, I'm left with an x. If I take 2x minus 1 from this term, I'm left with a plus 5. And it's equal to 0. Great. So now that I'm solving, I have two things multiplied to 0. So that means either this one equals 0, or this one equals 0, or both of them equal 0. And so I'll just need to solve this. This will be two steps. I need to add the 1 over. So 2x equals 1. And then divide both sides by 2. So x is a half. And over here it's simple one step. Subtract by 5. So x equals negative 5. So I have two solutions, either a half or negative 5. Awesome. So that's not that difficult. We could do special factors. We could do really hard factors, really easy factors. But if I can factor my trinomial into two things, each thing will be set equal to 0. And that's how we find the solutions. So let's move into some word problems to see if we can use this skill in a word problems. So you're walking to class on campus one day, and one of the infamous Francis Marion squirrels begins to wage war by throwing acorns at your head. The height of the acorn, h of x, is a function, after x seconds is given by the polynomial function. H of x is minus negative 16x squared plus 576. When will the acorn hit the ground? So let's draw something to help us. So this squirrel is up in the tree. There's my squirrel up in a tree, throwing acorns at you. And there you are, trying not to get hit with acorns. We want to know, how long will it take for one of these acorns to hit the ground? Once the squirrel throws it, how much time has to pass? Now, if we look here, x is our time. And so we want to know what x is when this is at a height of, what would a height of the ground level be? That would be a height of 0. So we are basically asking you, to find when this function is equal to 0. Oh, well, that's just what we've been doing. Now, I'm going to go ahead and tell you, having these big numbers and a 16 out front, I wonder if I can use a GCF. So let's get a calculator, because I don't happen to know my times tables up to 576 in my head. I wonder /hope/ I'm just hoping with all I have that 16 will divide evenly into both of these. Okay? And so let's see, 576 divided by 16. Come on, please be a whole number. 36, that's perfect. Now, because there's only two terms, and I'm left with a perfect square, and this is a perfect square, what if I wanted to make it a difference of squares? Notice the signs are opposites. So why don't I factor out a negative 16 as our greatest common factor? Okay, what's that? When I factor out a negative, it pulls the sign from each, so each sign. So this was a negative term. I took the negative out. I'm left with a positive term, and if I pull 16 out, I'm just left with x squared. This was a plus sign. Since I factored a negative out, this is now going to be a subtraction sign, and 576 divided by 16 was 36. Okay, now if you're confused on the sign, just distribute this back in and see if you get back this original. It should make sense. Negative times a positive is a negative. A negative times a negative is a positive. So if you would like to try to get a difference of squares and you have a positive here and a negative here in the wrong spots, you can just switch spots, or you can try to factor out a negative, and that'll help flip your signs. All right, now let's see if we can factor this difference of squares. Well, that's a pretty easy factor because that's a perfect square, that's a perfect square, they're being subtracted, so I know that'll be x plus 6 and x minus 6. Okay, now I have three factors that could be 0. Let's set all three equal to 0. So the first factor is just negative 16. Wait a second, can negative 16 be equal to 0? There's no x's here, so no, that's useless to us. But this factor could be equal to 0, and this factor could be equal to 0. That makes more sense. And so let's solve these. If I subtract, let me get a different color. I did everything in white and it's all running together. If I subtract 6 from both sides, that'll be x equals negative 6. And if I add 6 from both sides, I have two answers, two possible answers, negative 6 or positive 6. Now let's look back at the problem and see what makes sense. We're asking how many seconds have to pass before the acorn hits the ground. Can I go backwards in time? Can I have negative 6 seconds? No. So because this is a word problem with context, what's usually going to happen is only one of our solutions will be good here. And so it's this positive one. So when will it hit the ground? It'll hit the ground after 6 seconds. Okay. And that's a simple problem of solving a parabola here. If I were to draw the rest of it, you'll see this is that beautiful parabola shape. We're just trying to find where they cross the height of 0, or where they would cross the x-axis at. But we can't go backwards in time, so we're kind of cutting off right there. Okay, so that's not that hard of a word problem. People get panicky with word problems, but this one is just, hey, here's this function. Find when it hits the ground. Oh, that's just find when the height is 0. Find when it's equal to 0. One more word problem, then we'll turn you loose and be done for the day. So this one says, look, we have a small yard, and the width, let me underline some things, the width is 7 more feet than the length. So let's write that down. If we have the width, it is equal to the length plus 7. It's 7 more than that. So does that make sense to everybody? I haven't even read the whole problem. I probably should read it all first because I may not even need this. But just trying to make sense of stuff, the width is 7 more than the length. So if I took the length and added 7, that would give me the width. Does that make sense to everybody? Now let's keep going. The area is 30 feet squared. So if I have my little rectangle, I don't know what the width is, I don't know what the length is, but I know the area is 30 feet squared, and I know the formula for area. Area is just length times width, or width times length, or whichever way you want to write it. Just multiply these two things, right? So I think I can start to put together kind of a formula here. So the area is 30. That's not too bad. width times length. Well, this is kind of weird. I don't want to, that doesn't help me. Oh, but wait a second. Look here. I know that the width is just length plus 7. So I could write that as L plus 7 instead of W. So I can replace the W with L plus 7 because they are the same thing. They're equivalent. So I've replaced the W. So now look at what I have. I can distribute this L. 30 equals, let's see, L times L is L squared. And L times 7, that's plus 7L. Awesome. Looking good. Now, if I want to solve this for L, because what's the question? To find the length. I'm going to need to, it's not set equal to 0. It's not a trinomial. Wait a second. What if I were to subtract 30 from both sides? And so I have 0 equals L squared plus 7L minus 30. Okay. I think now, I'm going to write it over here again so I have it more neatly. I think I can work with this. Now I can put the 0 on the other side if I want to. So I have L squared plus 7L minus 30 equals to 0. So I have a trinomial equals 0. I'm feeling pretty good about that. So I need to be able to factor this, and then I can solve for L. Now, I know the first two terms are going to be L and L because this is an easy one. So what two numbers multiply to negative 30 that add to positive 7? That would be positive 10 and negative 3. That's negative 30. That would also add to positive 7. Nice. So I have two factors that equal 0, so I can set each factor equal to 0 and solve and have two answers. That sounds great, right? If I have two answers, how do I know which one is which? Which one's right? Are there two right answers? Does this thing have two lengths? Nah, let's just go ahead and solve it and see. So subtract 10 from each side, subtract 10, so the length could be negative 10. Okay, well that doesn't make any sense. Can I have negative 10 feet of length for my fence? I bet this one will give us the solution. So add 3 to both sides, add 3. L is equal to 3, so 3 feet. That makes much more sense. So what is the length? The length is 3 feet. Okay, so even though these typically give us two answers, when it comes to the word problems, one of them will be a throwaway, will not be make sense in the context of the problem. Okay, so that's not too scary of word problems. Those are the two types that we'll ask on this test. Nothing really nasty or scary there. I don't think there's anything super intimidating. But go ahead and try the homeworks. If you have any questions, please email me and ask.